way over there in the bleacher seats. So I'm this is one of my favorite spaces. So I'm just so thrilled that we get to come and spend time and talk about something I'm really interested in. Hopefully you are. I was originally the opening speaker today, but I got replaced by AI. So, yeah. Thank you to the sponsors, because that joke has really worked for like days and days. I really appreciate it. So this is me, the one in the doorway. Maybe you've had this experience. And so a lot of my career has been spent trying to understand, what does the person in the doorway need? How does the person in the doorway have a conversation with the people in the room? Why are the people still in the room? And early in my career, it wasn't like this. I was an engineer, and I built software, meaning we had one piece of software, and we put so much custom code into that one piece of software. So that was enterprise. And we were building it at scale, which meant we put varnish on top of varnish, on top of a router to moving traffic to more varnish. That's what we thought scale was at the time. And now my primary focus is, well, I do systems architecture. I'm a systems architect, which means that my focus is on relational complexity in software systems. And patterns of relationships between software parts are challenging, because when you take one piece of software and relate it to another piece, 1 and 1 doesn't make 2. 1 and 1 makes 3, because you also have the relationship and the qualities and challenges that arise once your system begins to depend on relationships. So a good day in my life is when the bug in production is in the code, right? Because it's usually in eventual consistency, which has become what we just mean by, we think it maybe should work this way, but we don't know for sure. And also, I don't just architect relationships in technology, right? I hear a lot of people equating architecture with Kubernetes. I'm an architect because I have Kubernetes skills. And some days I really wish that that was true. For me, in order to change relational patterns in a software system, I also have to change thinking and communication patterns within the people who are building that software system. So from a systems perspective, there's no difference between a social and a technical system. They are one interrelated thing. I won't read Conway's Law, because I think this room is generally familiar. If you've probably seen more than one of these slides today. But Conway told us this was true, and my experience has borne this out. So that is my introduction to me, and that is what I usually say when I give a talk. What I don't say, let me say first, I was an engineer, now I'm an architect. I have done work for organizations that you would recognize. I get to wear the rock star headphones now sometimes when I talk about it. But the other half that I don't talk about is that I was 33 years old when I tumbled into this career. Right? When I followed the white rabbit down the hole of I'd gone back to school to study physics, and I took a C++ course and fell in love with programming and the science of information technology. So I wanted to see how far the rabbit hole goes. This is one of the places the rabbit hole goes, apparently. And this was a big switch for me. So when I went to university the first time, I was a theater major. This is me in the high school production of The Crucible. I really wanted to be the lead, but they said I wasn't mean enough on stage. So I have worked to overcome that. I wrote term papers on a typewriter because we didn't have personal computers because there weren't personal computers. At least not for college kids in Boston. I made phone calls from the payphone because cell phones had just been invented and they were $14,000 a piece, right? We were spending our money on pot and then saving enough money to go to Steve's Ice Cream after the pot. These were my priorities. And when I left the house to go see a movie, like at a particular time. I read magazines. I once got an apartment because it was adjacent to the library, like always about access to libraries. I mailed letters. I used paper maps. If I got lost, I had to stop and ask a human for directions. Okay, I never actually stopped and asked people for directions, but in theory, I could have stopped and asked for directions. And so this year, the opening keynote was about AI. Previously, we talked about monolith to microservices, CRUD to event-driven. At the beginning of my career, we talked about print to digital. And at the beginning of my life, BASIC was invented. So this is not the way that Sapiens evolved. Like, we're familiar with this, but it's incorrect. If you don't watch QI, the British quiz show, you learn lots of things by watching it. This is one thing I learned, is that this is not an accurate map. But if you measure the change that humans have experienced, I have experienced the equivalent of 20,000 years of change in my lifetime. That's how much faster change, the rate of change is now. And I love my career because it requires constant learning, right? I think that brings a lot of us in, but learning isn't the hard part. This is the hard part. We don't learn. So there's a great insanity is doing the same thing again and again and expecting different results. And I have seen people, teams, organizations, countries, you might tell from my accent which one I'm talking about, make the same mistakes again and again, expecting different results. So at this point in my life, I've seen lots of change, but very little wisdom as a result of change. So of course, this became something I wanted to understand better. And so I've architected some pretty big digital transformations with teams and organizations, and in the end, they tended to look like this. All the CEOs that initiated the change were all gone 18 months later, a few by their own choice. So why? Like, when we have all this revolutionary technology, all this change, all this speed, all this bandwidth, then why do we keep hitting the iceberg? And this is the iceberg that we hit. And I'll say this in bluntly, we don't think in systems. Increasingly, we're faced with systemic challenges without the ability to navigate them. Tomorrow's closing keynote will be Kevlin Henney explaining why this is not a real iceberg. Icebergs are not shaped like this. And he will show you some examples of how I'm wrong in my depiction of icebergs. So definitely show up for that, yeah. So we react to changing events and the circumstances that are visible, but we don't often go deeper to understand the patterns and structures and core mental models that gave rise to those events. And so we might have experienced 20,000 years of change on the surface, but lurking underneath are often the same mental models, organizational structures, and patterns that reinforce them, which mean eventually we are going to end up with a distributed monolith in the cloud. If you've ever had that experience, it's very real, right? No? No one? Someone? Yes. I love this. If you've not seen this snarky site, Scaled Agile DevOps Maturity Framework, where they promise enterprise transformation without the risk of culture change. And I feel like if I had branded this myself 20 years ago, I would have gotten legitimate work from people not even understanding that I was being ironic. It names the iceberg. So according to Russell Ackoff, we're fully immersed in the systems age, right? That we are in a time in which, and we here in this room are absolutely experiencing this, right? Where the relational complexity, you have software in your pocket, all the things I mentioned, writing, publishing, movies, letters, asking directions, all of it is given to us now by software, and multiple software in stacks of software. Yet we've not sufficiently changed our mechanistic and industrialized thinking. So that, I would say, is why we hit the iceberg. The challenge is, what do we do about it? Because all the Kubernetes clusters, Kafka streams, learning language models, ChatGPT, open source, not open source, will not solve this for us, right? These are tools that help us, but we seem to think they will cure it, and that's actually not, as we've seen, that's not the case. So the true system, the system that we're constructing, is the system of thought itself. So keep in mind, right? We made all this up. Agile, we made that up. Kubernetes, we made it up. Kafka, we made it up. NewCrafts concert? Kinda. There'll be goats later. Conference in Paris, we made this up. We made it up, and we can make up other things as we learn and grow and evolve. When we are doing that, when we are looking and understanding the system of rationality, we're working on 4 levels. You are a system of thinking. Everything in production that you help put there is a result of what you thought about and what you communicated, yeah? Which means that all of our cognitive biases, bugs in our thinking we call logical fallacies, blind spots, they are all in production as well. And that's great, and we can't avoid that, nor would we want to, because that's part of how we discover, right, what works. But you can't improve your thinking without observing your thinking. And then we are a system of thinking. We here in this room have created temporarily a system of thinking. A team is a system of thinking, an organization, a country. And when you change a group or change groups, I'm sure you've experienced how very different the outcome of a system of thinking can be, right? It's a very powerful, constructive experience. And so we can change our system of thinking, and we can invent systems of thinking. This, for me, is a core skill in systems architecture, is inventing and improving or changing our systems of thinking in order to change the technology systems that are the result of our thinking. And so Pirsig goes on to say that if a factory is torn down, but the rationality which produced it is left standing, then that rationality will produce another factory. So the first time that my teammates and I went from monolith to microservices, 6 months later, we're like, these services are really tightly coupled. I think this is microservices architecture. No, it's because we still had CRUD developer mental models, and we did better, but we had a long way to go. It took us a few tries to understand asynchronous relationships, to understand where to put code and how to shape that system. We really had to practice. And so this was my first real valuable experience of that If I don't change my thinking, I will use new tools and build the same patterns all over again. And I am frustrated by our culture of forgetting. So we solve a problem, like increasing unknowns and micromanagement of technology initiatives. And we solve that problem with something that we called agile agility. Now, if I understand correctly from being at conferences, Agile is responsible for climate change. Agile will be the trigger of the zombie apocalypse. And what's interesting is when I talk to people about what was it that convinced you this is unworkable, they describe something awful, truly, truly, truly awful, but not anything I would call agility. Or they describe what they're doing instead, and it's the same thing with different names, and then not Jira. That's really the fundamental. We don't use Jira, therefore we're not an agile team, is kind of how this got had this. And so the thing is, do we no longer have increasing unknowns? Like, my favorite quote is that Agile was invented because reality refused to bow down to power. Is that problem solved? Because I didn't get the memo, right? Now, I'm not saying, yay, Agile in its pure form is good and everyone's wrong. I'm saying we learn, we grow, we change it. That was a first attempt, V1. V1 doesn't work for us, what's V2? But instead, we just cancel the thing we hate and reinvent something with different names that, shockingly, 3 years later, we have many of the same problems. So that's my little rant. And the end of my little tiny rant is that if we did iterate and improve as we learn and grow, you know what that is? Actual agility. So there's like deep irony in our lack of agility. So we'll explore 4 shifts that mirror these levels that I'm talking about. One is valuing knowledge work. The second we'll talk about is thinking well together as a core skill, as a necessary skill. Discovering leverage points. If you don't know what a leverage point is, I will explain it to you, so not worry too much. And changing the paradigm. Also going to explain what the words are, but I'm using systems thinking-y words for things that you actually know. Like when I give you an example, you'll know exactly where they are, but then also you can impress your friends with interesting systems thinky words that sound like they are sort of mysterious and meaningful. So the shift 1, valuing knowledge work. And my view is that systems architecture is knowledge work, building software is knowledge work. Software itself is encoding our knowledge, literally encoding our knowledge. Yet in my experience, we rarely approach activities as if they're knowledge work. Arguably, a person very responsible for this is Frederick Winslow Taylor. Taylor became a foreman. He was an engineer. He became a foreman. And what he discovered is that the people that worked for him failed to do and produce more than 1/3 of what Taylor thought they should produce. So this is the same as an organization saying, sure, you can do Agile, but you have to do 100 points every sprint, and then you have to do 10 more. Like, we're just going to decide what the quota is. So Taylorism became known as scientific management. And it's based on the observation that most workers who are forced to perform repetitive tasks tend to work at the slowest rate that goes unpunished. That we are all trying to trick our employers into thinking we are doing work. If you think about it for even 1 minute, you'll come up with at least a few examples of how this still informs the structure of business organizations. He called it systematic soldiering. So people who do the work, which he called soldiering, And the systematic means that they'll do the minimum amount of work allowable by an organization. So Taylor had an apprentice named Henry Gantt. You might be familiar with a Gantt chart, which we still use. Henry Gantt's family, until the American Civil War, depended on slave labor. They owned a plantation, they had slave labor, and they lost it in the war, so Gantt moved to Baltimore, where he became an apprentice of Taylor. And he became a very big proponent of scientific management. And they believed that knowing exactly what you want men to do, and then seeing they do it in the best and cheapest way. The fastest, too. So the 10x developer thing, they would love this. They would have paid you by lines of code. That would have been like, in order to make sure you wrote code faster, they would pay you by lines of code. So if you were a slow developer, you got paid less. So they also believe that managers need control over people's bodies. So we see this today, right, in the back to the office movement. So CEOs, there's a study that CEOs were asked about working from home or hybrid working, and the majority of them believed that there was a tremendous hit to productivity, this was problematic, but simultaneously, there were studies that actually did measure what was happening, and we are slightly more productive when we work hybrid. So this model, this idea of management is so powerful that we are still operating from it even when there is reason to think that it doesn't work. So if the core mental model that we're operating under is that workers avoid work, workers are lazy, workers have to be managed, then we would need to build a structure that's a hierarchy to control productivity, right? And Jira screams in. I don't actually mind Jira, by the way. I'm going to make Jira jokes today, but I'm not hating on Jira. It just, Jira has this software, this as a piece of software, it helps with this. And so this leads to task-driven development, right? So the focus is on organizing tasks, getting them as low level as you can, and then getting them done as quickly as possible. And then what this leads to then at the surface is we're all spending our day meeting expectations. That's what we do. We're meeting expectations, figuring out what those expectations are and meeting them. Now, I'm calling it normalized expectations because we don't even know that there's another way of living, right? That this is so ubiquitous that we think that this is the way. And we're taught to expect this from a very young age. So Peter Senge says, we'll never transform the prevailing system of management without transforming our prevailing system of education. They are the same system. I wish we had more time because I'd love for us to really dive into this. Like, there's just so much to say about this. But we don't, so I'm just going to leave you with the idea that the way that we think and operate is not just tech industry. There are a lot of systems around us reinforcing this so that it makes it even more difficult for us to imagine a different way. So Larry Pirsig, who absolutely has been my mentor on knowledge management, who passed away last year, he says that those companies that don't adapt to understanding knowledge as a force of production will slowly die, and they'll never know what killed them. So one of the things that we kind of have going for us is that despite the resurgent prevalence of task-driven development done by command and control people, I won't mention the social media platform with the bird on it that I'm actually talking about, but if you've been in software for any length of time, you know that those approaches tend to make a mess. Not always, but personally, I see a lot of things that are red flag, not because I don't like them, but because I know where that road leads, Neo, and I know I don't want to be down there, right? So I want to pause for a second because we talked about knowledge this morning a little bit with AI, and I would call that what AI generates, mostly I would call it information. So I have a very long-winded definition of what I mean by knowledge, and this still isn't right. I don't know, I might die before I actually know how I want to describe it. But it is the synthesis. It's the ability to take in information, to have experiences, to operate from a sense of values or heuristics, to have expert insight. You've seen patterns, to have a bit of intuition, like you get a sense of how something operates. You synthesize that together to generate artifacts. I mean this very generously. Artifacts or software, code, models, documents, conversations, routines, processes, cultural norms, organizational practices, and that they are valuable and insightful in a particular context. Knowledge by itself is of very little value in the general sense. Knowledge is matterful because it has a positive impact on something that benefits from that impact. So Larry also talks about two other things, and Akoff does too, that are really important for us to understand. One is the difference between knowledge stock and knowledge flow. So knowledge stock is the store of knowledge you have, or that you can have access to. And generally, knowledge stock increases your efficiency. When we hire engineers, this is usually what we test. A whiteboard test tends to mostly test your knowledge stock. And when Larry talked about the benefit of knowledge in an organization, he meant knowledge flow. So knowledge flow is your ability to transfer knowledge between people or between people in tech or whatever you're building your solutions in ways that change and shift the system. So knowledge flow generally increases your effectiveness. So you're always looking for the combination. Enough knowledge stock to be efficient and enough knowledge flow to be effective. So Larry had said that emphasizing knowledge stock to the detriment of knowledge flow is the most significant mistake that organizations make. I would say it's a significant mistake that we might be making as an industry, right? So if we don't do this and instead we look for this, can you learn new things? Can you adapt to new circumstances? Can you help others to learn? That set of skill set in the systems age, in technology, is what helps to generate knowledge flow and generate more value over time. More signal, less noise. So if the core mental model is that our expertise, critical thinking, and interpersonal skills generate value. And I love saying this out loud. I want to say it again. Expertise, critical thinking, and interpersonal skills generate value. Like, that's the work I do. I do that work, I become good at this work, and then I generate value with the work. So then we begin to create hierarchies that support the growth of these skills. Right? So the role of leadership, for example, is as much as possible to create an ecosystem in which these skills can generate increasing value. And so this would lead us to patterns that look more like initiative-driven development. Or as Trond, if you saw Trond's talk when he talked about DP1 and DP2, DP2 would be something much more conducive to initiative-driven development, where there's a problem to solve and you give it to the team. And then the team works together to figure out how to solve the problem. And what this means for us is that every day you work, you increase your value. You increase your personal value to the world at large, and you increase the value of the organization. And I am really perplexed because I have a bit of an entrepreneurial spirit, for sure. And I'm like, doesn't this obviously make more money? Like, this just seems like so clearly more economically beneficial. But there's McDonald's that proves me wrong. So then we have the question of what then is, if we're saying management has this particular point of view, what would leadership be for systems thinking and for knowledge work. And the core mental model then in providing leadership, which can be done by any role, is to synthesize knowledge and maximize its impact. Meaning, if Sophia and I are on a team, what we want to be able to do is something hard that neither of us could do alone. And then we add Aki. And now we can do something way harder that none of us could do alone, or none of the two of us could do alone. So this process of being able to using synthesis of knowledge to maximize the benefit of knowledge would then give rise to tools and processes for generating knowledge. So right now, I'm architecting a greenfield platform with a team I got to build myself. This is awesome. Like, when I work with people that everybody I want to see, everyone I know their habits and they know mine, and I don't know how long it will last, but for right now, I'm like, this is wonderful. And we're struggling because Jira, in the sense like we're trying to describe a system and the interrelationship between the models and the diagrams and the parts and the code and the original idea for what the platform should be. And I'm like Obsidian or Notion, or I have like 7 tools talking to each other, and I'm writing scripts, and it's still not really working, right? So part of what's happening is the more we have these knowledge work patterns, the more we'll have tools that help support our work. And then the pattern is knowledge flow. That's what we're doing here, right? That you learn and experience something, and then how do I enable other people to also have this experience if it benefits them? And then the workday is to think well together, right? That, again, in the Sophia example, is the ability to come together and do hard things that you can't do alone. In my world, there is no hero, genius, developer, person who saves the day anymore. It's too much complexity. No one knows everything about everything. We have to be able to shift perspective and work cross-functionally, or we can't. We're very limited. So thinking well together. This is an improv team. Has anyone not seen improvisational comedy? Whose line is it anyway? Good, because you know what this is, right? That these are, okay, so these are actors who go out on stage and ask the audience, who are we? Where are we? What are we doing? And they just make up the play in front of you. It's terrifying. It's truly terrifying. Although I will say, between studying theater and doing improv, my family telling me my life would amount to absolutely nothing because I would never use those skills, I do feel like right here, right now, I am demonstrating that skills outside of tech do benefit your technology career. Okay? So this is the ultimate generative team, right? This team is in real time thinking together. And they have one rule, the yes and rule. So if I do something improvisationally, my acting partner, in their mind or body or even in their work, yes, they accept what I'm saying. They lean into what I'm saying. And they take it and they add something even more funny or even more interesting. If you've ever seen, which you probably haven't because it doesn't happen at the professional level, if you've ever seen an improv team and someone says no, the whole thing, and you feel it. Like, it's like a stand-up comedian that got booed off the stage. You can feel it in your body when it happens. Think of the last 4 or 5 meetings you've been in. How much yes and were you experiencing in the relationship? And I don't mean agree. I might say, oh, so you're saying the API, these API responses are too slow, therefore we need Kubernetes. That will solve the problem. I might not agree that this is it, but I acknowledge that's what you're saying. I try and make sure I understand the problem you're trying to solve, and suggest that Kubernetes is potentially not appropriate in these ways for this thing, right? So this one change is the lowest level, littlest change. It's incredibly powerful. Give it a try, where you just repeat back to what the person is saying or acknowledge them or answer, and then do what, because we're really into opinion giving. This is our culture very much. I don't do requests for comments anymore because I just get everybody's opinion about what it is I think. And that really doesn't do me much good, because what I need is you to help me understand how you came to that conclusion, right? This looks like a graph, and graphs don't scale. What convinced you that graphs don't scale? Isn't the internet a graph? Maybe under certain circumstances they do scale. So we can't get anywhere until we're actually engaging with the things underneath the surface, and opinions are our surface. We're a very big no culture. You might have had this experience where you say something and the first thing you get back is why you're wrong. Right? The XKCD cartoon, somebody's wrong on the internet, is the 5th most popular XKCD ever. And I love that. I mean, I love having arguments about, about everything, actually, which programming language, or like all the things. But when we're doing systemic reasoning, what we're doing is synthesizing knowledge, experience, and then using sound judgment to create recommendations that are based on valid reasons. So when we're thinking well together, we're showing our work. Remember this from math class? You couldn't just give the answer. You actually had to show how you came up with the answer. This is a core of thinking well together, where we show how we came to these conclusions, and often we discover there's a tremendous amount of things we have in common, better than if we get stuck in a binary, right? In the yes, no, right, wrong. Kevlin's wrong about icebergs. 100%, right? And so Fred Brooks says that conceptual integrity is the most important consideration in systems design, right? So I disagree with a bunch of things that are related to this. And what I mean by conceptual integrity is the ability to think well together. It doesn't, not so much that this is definitely not saying everything has to look the same or be designed by one person. This is basically saying your software system is a family at American Thanksgiving. Do they enjoy it? Do they get along? Do people bring food? Or is drunk uncle over here and the kids are over here setting things on fire and 3 people don't speak to each other and 2 don't come? That kind of ability for the software system to have some cohesion even in its differences. So Brooks said that the antithesis of conceptual integrity is many good but independent and uncoordinated ideas. That's every code base I've seen, for the most part. Many good, but independent and uncoordinated ideas. So the example I use is the car boat. One part of the organization wants a car. One part of the organization wants a boat. So they tell the engineers to build a car boat. Everybody hates the car boat because no one wanted a car boat. Don't want a boat, wanted a car. So we have this inability to design capabilities in a way that helps us to understand what the system most needs to do. And instead we do sort of a requirements-driven engineering, and we end up with this really cool car boat that actually doesn't meet our needs because, for example, the car people needed something that you could drive in the snow. This is not. So if our goal then is to deliver an impactful outcome that improves the system together, right? That's where we're working together. Then we need patterns of systemic reasoning that are reinforced as the norm, meaning we don't do opinion giving, we don't do let me tell you why you're wrong about this, well, actually. I mean, you know, sometimes, but generally speaking, we're trying to come up with a recommendation for action in complex circumstances. There is no one right thing to do. That doesn't exist most of the time now. So what's the best possible thing in your circumstances based on the highest value needs of those circumstances? That's really hard. It's incredibly hard to work and improve a system. So we can make it less hard by listening to each other and making the process of trying to think together easier. And so the The structure then are processes that help to construct conceptual integrity, meaning just enough interrelationship between parts of the organization or teams that we're able to work together while still having the necessary space and autonomy or whatever it is that we need for our subsystems, right? So the overall system has, again, a family at the holidays. And so the core mental model is that teams are greater than the sum of their parts. That what you're actually trying to do is bring people together so they can do hard things they couldn't do without the together part. That's what we're designing in an event-driven system, right? That in a decoupled system, microservices architecture, we are designing parts that by themselves don't do what we need it to do. It's the relationships between them that give us the emergent behavior we want. So we do the same thing in the people. So leverage points. Really simple. I got to use the big words. Now, leverage points only means places to intervene in a system. It just means the change you want to make. The reason leverage points are very hard is because most of the time we're making changes in the system that make the system worse, the vast majority of time. To figure out a change in a system that improves the system is very difficult. And so we do, so give you some examples of leverage points. These are low-level leverage points, but they are leverage points. Auto-scaling, caching, continuous deployment, test coverage. These are ways that we're intervening in systemic relationships in order to improve the functioning of the system, making the system better able to serve its purpose, right? And to do the things for people that it needs to do. So the reason that, sorry, I just pause and be like, I have a beer slide. Maybe we could just enjoy the beer slide. But I'll tell you a game while we're enjoying. I'll tell you a story. So the beer game was invented by Jay Forrester, systems analyst, taught us so much about understanding systems. MIT, is it funny? I'm going to say it because I really had. MIT does it with all of the masters in business students. I don't think it's helping, but they do. They do play the game. It's a very straightforward game. You over there, y'all, are a really cool craft beer store in a really cool city. Like, I'd say Austin, Texas, but Texas is in the words. So whatever your coolest city is, you're a craft beer store. You here, you're the distributors, which is boring, but you make the most money. Yeah. You are a brewery that makes a cool beer that tastes like butterscotch. I don't like beer, so I don't know if beer tasting like butterscotch is a good thing, but no. Okay, we're going to go with it anyway because it's kind of a fad thing. You're doing the butterscotch thing. Okay. The system of communication is this. You have a form, digital form, that you fill out with them. You have multiple digital forms that you fill out to this brewery and your other breweries. Then they give you beer, and you give them beer. Right? Makes sense. Okay. So Taylor Swift, have you heard of Taylor Swift? I said? Okay. We needed the GOAT for this. Taylor Swift is at the Super Bowl. Do we know what the Super Bowl is? There's a sporting event, yes. Soccer. So, right? I once did a talk with 200 people in the room in the US, and I asked them who was playing Monday Night Football. No one knew. And so I showed a picture of Tom Brady and Peyton Manning. No one knew who it was, but someone Googled and said, the New England Patriots. I'm like, yes, you knew. Like, no, I Googled. Someone went on social media and said, 200 people, no one knew the stupid football joke. This is why I love tech. Which, of course, just made me make football jokes in every single talk until I got tired of it. Anyway, Taylor Swift is at the Super Bowl, the American football thing in which we think that the whole world cares about the Super Bowl. we really do. We think you're all at home, like staying up late, watching the Super Bowl. She drinks the butterscotch beer. So, of course, everybody has to drink the butterscotch beer, right? So you get a whole bunch of customers coming to you to get more butterscotch beer. And you know you've run out. You've asked them for more, but they have their process. Oh, y'all. Like, I mean, how you got to get new equipment and new butterscotch. I don't even know what butterscotch comes from. And hops and things like that, right? Like yeasty things. You have to get more of that kind of stuff. So the system has a delay in it, right? So what happens when you start experiencing the delay? You start having theories about why you're getting by the beer industry, and you overorder to try and get more, which means you have overorders, and you're actually squirreling away some of it for some of your favorite people who order more, like Amazon gets some, but they don't get some, and you have all these strategies, and then you're just like trying to spin up beer as fast as you can, and everybody loses the beer game. By this, I mean they end up with a giant pile of beer that nobody is drinking, because it's butterscotch beer. Like, it wasn't going to last, right? You end up with a giant pile of beer. You can win the beer game if you all just went, let's all whiteboard and model the delay time between the beer so I can see what's happening, and then you can anticipate if you made information transparent. Nobody ever does this, even CEOs of distribution companies, right? Because it's not how we think. This is not the most important thing about the beer game, though. The most important thing is, I ask you, why did this happen? And y'all say, them. And I ask you, and you say, the market and the competition and them, and you're like, we don't know what butterscotch is. We were like, someone made that up when they were drunk or whatever. Like, the point being, in systems, we almost always are blaming the wrong thing. And this is really important to know, that most of the time, when there's a big emergency in your software, and you decide what's causing it, right now in this room, you're thinking of things maybe that's happening at work, and you're wrong. And that's okay, and we can't avoid it. But when we're aware of it, then we can then continue on to look for leverage points. The challenge, though, is that people who know a system, they often intuitively know where to find leverage points, but they do the wrong thing. So we don't just blame the wrong thing. We then do the thing that makes the problem worse, like in the beer game. Over-ordering and hoarding beer and is actually causing more of the outages than there would have been if there was just a delay in the system. This is our most famous example. We call it counterintuitiveness. Counterintuitiveness is what tells us to do something and the thing is wrong, which makes sense because we do the thing we think we know, but this is a new problem. So we have to do a thing that isn't a thing we know. So this one, adding manpower to a late software project makes it later. And if you've ever had to talk to a manager person about why that is true, you know it's difficult to explain why this is true. But we know from experience that it is. So most of the time, we are the cause of our problems. The call is coming from inside of the house, right? But we are blaming outside circumstances, leadership, junior developers, Agile, Jira. These are our Kubernetes. These are our problems or our saviors, depending on your point of view. I have one more bit of bad news, and then I'll move into the better news. Donella Meadows says that we know from bitter experience that because of counterintuitiveness, when you do discover a system's leverage point, nobody's going to believe you. I call this the 18-month rule. You might have experienced this. Seems very clear that making this change would be good for everyone, and so you say it, and everyone tells you you're wrong. and you're not wrong, so you continue to say it, and you prototype. I have 4 prototypes in my personal GitHub repository running in AWS because no one wanted it after I built it. So you do other things, 18 months later, the organization says, basically everyone says, we always knew that. We always did it this way. What they will never do is come back and say, and Diana told us 18 months ago that this was the way to go. That will never, ever happen. But generally speaking, it takes time. This is a joke, but also my life. Of course, pretty much every system I work on has both, but the massive amount of iceberg-level mental models, patterns, and structures that we learned as CRUD developers are very challenging. Eventual consistency, you think that I was suggesting the most vile thing ever in the history of the world to people who are very transaction-oriented, right? So how do we shift our thinking towards a leverage point? So if our core mental model is the most valuable change is a leverage point, then we have structures and processes that evolve our ideas and encourage us to uncover our blind spots. That we know if we've come up with a solution, that's great. Also, we've come up with the next problem at the same time. So can we also work with the fact that we are making things better and we are always making things worse? And so this reinforces pattern thinking skills, meaning that we begin to pay attention to how relationships produce effect. How do changing relationships in a software system, in the information being transmitted, in the tools that you're using, in the people that are working, how are those patterns contributing to the problems that you see at the top of the system? And this leads us to design for emergence, which I really mean when I say this, that we know shit's gonna happen we don't expect. But it's also good for us because that's innovation. Innovation is you do a thing and you get more benefit than you expected. Failure is you do a thing and you get less benefit than you expected. So you gotta go for it, and then you get to discover, because you can't really know which of those, what is it, the lady or the tiger story? Choose between the doors, one lady and a tiger, kind of that. So the way that we avoid the iceberg is to transcend the paradigm, meaning to be able to ask ourselves, hey, is everything we think is true and right and best practices, but we keep having the same problem? Maybe one of our best practices is causing the problem, right? Maybe that, and maybe it's not. But it's the question, it's worth asking the question. So not all leverage points are equal. The most impactful leverage point is to change the paradigm. The paradigm is the mindset out of which, question, time, okay. We're at a really fun part that I was gonna go slow with, but I'll go faster, and it'll be provocative, and it'll be the things you wanna ask me after. Okay, is the mindset out of which the system's goals, power structures, rules, and culture arise. In the tech industry, we are a system that has structures, rules, cultures arrive. We cling to some that fit us, and that's fine. We often, paradigms shift around us more often than we shift them. So often we are actually responding to circumstances changing. So here's an example that I would encourage us to find a leverage point around. According to a 2022 study, 91.88% of software developers worldwide are men. Knowing what you know now about we're blame the wrong thing, counterintuitiveness, call is coming from in the house, we have mental models, we're trying to understand now, how does this happen? Setting the goal, hire more women, doesn't work because that's a surface goal. I've been in tech for 20 years. I know that women who have been in tech for 20 years are gone. 95% of them have left. So it's not just having women in tech, it's keeping us here. But the reality is we're blaming the wrong things. We're having binary conversation. Like, we actually don't really know why this is happening. And it's the kind of conversation that we can have. We're also reinforcing it. The mom test, the mother test, the girlfriend test. Anyone not familiar with this? So last year, here, the keynote speaker mentioned talking about tech skill and said, yeah, but you still have to help your mom with her little baked goods site. Half of the speakers here are women. A lot of us are moms. Pretty much don't need your help with my little baked goods site. I don't bake, my husband cooks. So like this. But I truly felt it was well-meaning. And of course that's what people say, because most people's moms aren't standing up here with tattoos and blonde, this is supposed to be blonde hair, talking about systems architecture, right? Like, so we're doing this and we don't even realize we're doing it. But if you've seen my son and I playing endless weekends of Marentha with a Telnet client, full, anyone old enough to have played MUD when you did no images? You all text, yeah? We would be in the same room all weekend, not speaking to each other, only engaging in game. So now the mother test in my life, my son says I write better regular expressions than my mother. My son does write better regular expressions because I do not value that skill. Not at all. Yeah. My son loves when someone makes the mother test reference because he says, my mom has root access. And he likes it because the person he says it to doesn't know what that means. Okay, so the last one then. If we want to do hard things together, we need agility, adaptability, diversity, the ability to evolve our thinking patterns and ideas. We need impact. We need to consider the impact of our patterns on everyone involved in the system, and we need to evolve our thinking as our work. This is what we're doing. Okay, so imagine the next time you hear the mother test. 20,000 years of change in my lifetime. How many paradigm shifts have I had to do to be standing here today? And if you haven't had this experience yet, it's coming for you too. Staying in this work is about being able to adapt to change, to design change, to be able to let go of what doesn't work and evolve what does. So if no paradigm is right, you can choose whichever paradigm works. That's the power that we have. So when you feel like a cog in the system, imagine that you are the architect. What would you change? I have a book coming out. If you go to learningsystems.com, you'll learn about the book and the library and a community that we're developing in between when we're together. And also be sure to listen to Kevlin explain to you what icebergs really are. All right, yeah? I'm sorry that we don't have time for questions because I overused my time. But you're so fun. Thank you so much for being here.